Folks, we come to the part 5 video of this exercise, miscellaneous exercise, and some crucial problems we have finished. I think coming problem should be a little more lighter as compared to the previous one, but let's take this problem. Problem number 7 says that a man running on a race course. Please visualize a race course. How is it? A man running on the race course notes that the sum of the distances from the two flag posts from him is always 10 meters and the distance between the flag posts is 8 meters. Find the equation of the post traced by the man. So race course, once it is to see, it's more or less clear in our mind that it should be a circle or it should be an ellipse, right? And circular race courses, that is too much, right? Because it's very difficult. We know that it will create, there are the others, the other centripetal and all such kind of accelerations and all that, that makes it difficult. So generally it may not be circular race course. So 9 out of 10 chances that it's an elliptical race course, right? So we will assume that it's an ellipse and we will try to put up the data and we'll see whether it is suiting fine for it. So assuming that this there is an elliptical race course, there is a race course. This man is running on this race course, assuming that this is a race course. Notes that the sum of the distance from two flag posts is always 10. So there are some two flag posts here, and this man is somewhere. It can be anywhere. Okay, the man is running, so he can be anywhere. And the sum of the distance, suppose if I call the flag posts as A and B, then he notes that the sum of the distance is always 10 from those flag posts. Sorry, and the distance between the flag posts amongst themselves is 8 meters. Distance between them is 8 meters. This is the data that they have given us, and they have told us that find the equation of the post traced by the man. Find the equation of the post that is traced by the man. So he's the equation of the ellipse, that's it. So it's determined that it's ellipse. Why? Because they say that the distance of this man from the two flag posts is constant, and that is 10. This happens in an ellipse. When we see the construction of the ellipse, every time we have got some base for a construction, right? For parabola, its distance from the directrix plus, that kind of condition is there. So it is a condition for the ellipse that the variable point on the ellipse, when you take its distances from the foci and take their sum, that sum will be always a constant. So that's a condition. So it's because on the basis of that condition that we are deciding that yes, the question that is given to us, the race course, it is an ellipse. Having decided that, we should have a coordinate axis, etc., and we should see how it is. So let's have this P somewhere else so that it doesn't collide with that. Assuming that our coordinate axis is like this. Yeah, so assuming that our ellipse is of this kind, x-axis, y-axis, point P is anywhere, it can be anywhere, but the distance is always 10. That is what they say, and the distance between the two foci is 8. A and B, those points are foci. So that is to C is this, and always this constant distance is 2A. That's how the ellipse formation is happening. That constant distance that happens is always 2A. So it gives you A, you get C. Both are there with us. See, when we read the theory of the ellipse, this will be very clear to us that whenever you have a variable point on the ellipse and its distance from the foci is taken, the sum is taken, whatever answer that you get, that answer is actually 2A, and that is what helps us in forming the equation of the ellipse also. So that way this will become 2A, and because the distance between the two foci is given, we know that the distance between the two foci is C. Why? Because the equation of the foci is plus or minus C0. So this is C0 and this is minus C0. When you add up their distances, it will become 2C. So you get C also, you get A also, you will be able to get B from there, and that's how you are able to get the equation of the ellipse. So it's just a matter of deciding the shape, putting up the things, and then working. So let's work with this. So let the race course be as shown in the figure. Let the race course be as shown in the figure. First thing. Then next thing is here A comma B are the foci, and P is the variable point. P is the variable point. Right, it's of type 1. That we have decided. Therefore, its equation is x squared by a squared plus y squared by b squared equal to 1. Given that PA plus PB equal to 10, which is 2A, according to what we have learnt. Therefore, we know that A is 5. Also AB equal to 8, which is 2C, C plus C. Now I am looking out for the units, meter, yeah, it's meter. So 2C, so like that C will become C will become 4. Also, what do we know? We know that C squared is A squared minus B squared. So that is 4 squared is 5 squared minus B squared, which makes B squared as 5 squared minus 4 squared. By triplet it is 3 squared. So we'll have B squared as 3 squared. Therefore the required equation is much simpler. X squared by A squared, what is that? 25 plus y squared by b squared, which is 9, equal to 1. X squared by 25 plus y squared by 9 equal to 1. So it's only a matter of deciding that this, and according to me the crucial point is to decide that this is 2A, and this will be clear to you only if you are very aware of how the ellipse was formed. We have the theory as to how an ellipse is formed, as to how a parabola is formed, so as to how a hyperbola is formed. So if that theory is clear, we get to know this has to be 2A. So that's how. Then once that is done, then the working is clear. And once you are able to trace that these those flag posts, they are the foci, then that's it. So I think are the foci are the, I think here we can be more specific, are the flag posts, isn't it? Let me make it more clear. Are the flag posts, and then you can write in the bracket foci. Things become more to the context. So the equation traced by the man, P be the variable point or the man, where the man is moving. Right, so that is our problem number 7. Now we are going to the problem number 8. An equilateral triangle is inscribed inside a parabola y squared equal to 4ax, where one vertex is a vertex of the parabola. Find the length of the side of the triangle. So since they have told us right away, let's get the parabola. They have said that it's a parabola y squared equal to 4ax, where a triangle is inscribed with one vertex as the vertex of the parabola. This is your y squared equal to 4ax. Here we are getting an equilateral triangle such that one of its vertex is the vertex of the parabola, as usual. OAB is your equilateral triangle in which you have this is how it is. For this equilateral triangle, you have to find out the side of the equilateral triangle. If I am not mistaken, find the length of the side of the triangle. So we have to assume the side, and then we should start our work. All right. So let the parabola be as shown in the figure. Parabola be as shown in the figure, and triangle AOB be the required equilateral triangle. Also, you have this OC, which is perpendicular to AB, because the coordinate axis is coming. The place where it is meeting, we are calling it as C. That's all. Okay. Now, see, it's very difficult to work like this. So let's call the side. Let OA equal to OB equal to AB be some side K or anything. You can assume that side as anything. Let it be some K. BK. That's what we are assuming. See, we are assuming. To indicate that we are assuming, we write in the bracket C. Right. So you've got this as each side as K. Is OC special in any way? Is there any speciality that OC carries? Yes, it is an altitude of that triangle, isn't it? And altitude of an equilateral triangle, we have learnt in the 10th standard, has a formula that it is root 3 by 2 into side. So let's use that. Therefore, altitude OC is equal to root 3 by 2 into side, which is root 3 by 2 into K. So you get to know that this length is root 3 by 2 K. You get to know the coordinate here. This is root 3 by 2 K comma 0. That's clear to us, right? Now we also know that the side AB, right? Side AB is K, right? And because you have the axis, we know that a parabola is symmetric about the axis. It has to be K by 2, isn't it? So that we observe that AB is K. So therefore AC equal to CB will be K by 2, right? That will help us to get the coordinate of A. Just check. Therefore, coordinate of A is equal to, this is the coordinate. What is its x coordinate? It is root 3 by 2K. And what is its y coordinate? It is K by 2. That's it. So you've got the coordinate. Now because it's a point on the parabola, it will satisfy the equation of the parabola. But A belongs to the parabola. So it satisfies the equation of the parabola. Satisfying means substituting for x and y. So what will happen? The y squared equal to 4ax will become K by 2 the whole squared equal to 4a into root 3 by 2k. So let's solve this. This is K by 2 into K by 2, 4a into root 3 by 2k. K you can cut, one of the 2's you can cut. How about A? A will be K by 2 and A will stay here, 4 root 3 will come. So we'll get A as K by 8 root 3. Okay, what does the question say? Find the length of the side. Okay, so what's the length of the side? It's K. 8 root 3A. Let it go on the other side. The length of the side is 8 root 3A. Therefore, the required length is 8 root 3A units. That's about it, and that's how we finish our 8th question. With that we finish the exercise and the chapter, and we are meeting in the next video with the chapter number 12. Thank you.